Morning, gentlemen. What's up? We're back into the K24. This guy here just got the block finished last night. So next up is our con rods. So what we need to do is measure this hole. Essentially, need to torque it down, test our stretch, measure the hole, and then compare it to what is on the crank. So you can see down there where our con rods connect to on the crank. We need to measure that. We need to measure the hole, and then that'll give us our oil clearance, and that'll tell us whether or not we are in spec and good to bolt it all together and send it. So that's what I'll be doing. It's just going to be a quick time lapse because it's not exactly that interesting. It's all this kind of maths crap. And then from there we'll move on to the next step, which is going to be speccing the pistons. We're going to check our piston wall clearance and all of that, ovality of the bore, all that kind of fun stuff. Yeah, let's just keep moving on. Been a minute since I've done any of these, so I'm just going to slap some more of this stuff on. This is just your ARP stuff. Use generic, you usually get it in smaller tubes. If you don't do this too often, molly that bad boy up. And what this does is gives you repeatable, even torque across all the bolts, reduces friction equally, all that kind of stuff. So the theory goes. Actually really love the smell of it too. So all we're doing is nipping both of these up. What we want to do is make sure our cap is seated properly too. What I'm going to do right there. And then from that point, I'm going to back this guy off so it's loose, finger tight again. The only issue with this is now when I go to put this on, it's going to face the other way for you guys. But what you can do, so what we're trying to do, you can see I've already zeroed it, is to see what the length of that bolt is, right? And the reason we want to know the length of that bolt is because when you tighten it, all like steel structures, aluminiums, metals, all of that, they've got a yield strength, which is like if you put your arm in a vise and bend it and bend it and bend it, at a certain point it's going to break and it's not going to be any fucking help, is it? It's not going to be useful for anything. It's the same with a bolt. You've got a yield strength. That's its maximum usable strength. If you go over that and you break, it's not any good. I mean, the bolt won't physically break, but it will be more prone to breaking, and when your crank is yeeting back down without any pressure on top of that piston, it is yanking on these bolts. These have a hard bloody life. So what we're trying to do is tighten every single bolt up to yield, their yield point, so it's their maximum strength that they can provide without going further than that. You can keep doing this yield strength over and over and over and over and over. You can keep using these bolts over and over and over until a certain point, and I believe ARP gives you 1,000, I think it is, yeah, like 1,000th of an inch tolerance. Once it's past that, boom, done. Can't use it, it's cooked. Yeah, so what we're doing is we're measuring it seating or pre-seating before we tighten it, and we have our gauge 0, so that's it. 0, 0, no, nothing, 0 zilch. And then we'll start tightening it down. So we're not actually going to use a torque spec specifically. What I'm going to do is I'm going to tighten, this one's only hand tight, this one here I'm going to torque up to 20 newton meters of torque, and then we're going to check our stretch again, and then we have to decipher this jargon. So these guys obviously aren't an English company. Tight progressively in 3 steps to reach 0, 11 millimeters to 0.15 millimeters full stop stretch. Do not go over 6,22 kg XM or 45 foot-pounds? Yeah, righto. Well, for one, these are 55 foot-pounds for every other manufacturer, and these are a little bit under as well. So, what can you do? We'll go to 20 foot-pounds, or 20 newton meters, and then we'll yeah, step it up. We'll go to the next stage and just try and work through these rods. Yeah, north here. Oh, I can turn that with my saw hand. I only stuck the screwdriver in it last night. How'd I do it? Yeah, but hang on, get this piston back to the top. And about TDC there. So we got the one piston in. Obviously you want to make sure that you have your pistons in the right way. This is intake, exhaust, as you know it is on the motor. Just check with your valve pockets and kind of align it on the head if you're not sure, because you don't want to go through all that, have it in the wrong way. I have done that before in the early days of this. And also make sure that you've got moly on both sides of the crank. That's your assembly loop. Both sides. You saw that I forgot to put it on the conrod side, so I just push the conrod down a bit, put some moly on there, chuck the back up, and we're good to go. So yeah, that's one piston in. I'll continue on and do the rest of them, probably maybe time lapse, I don't know. So been doing it in 4K lately, so it's a little bit more data, takes a little bit longer, but hey, is what it is. And you can see that I'm also going through and making sure we've got the correct stretch on all of them, not the torque but the actual stretch, just to make sure she's 100%. Yeah, so I'll continue on, I'll get all those done. Man, it is still raining. Anyway, rods and pistons are all in. We're good to go. Spin nice and free. Dun, dun, dun. No weird noises, oil squirters clear, all of that stuff. So we're back to number one TDC. Oh, a little bit faster. Boom, done. So there we are. How good does it look as well? Always love this part. Anyway, next up we're going to be dealing with an oil pump. So I can already see that there's flakes in there from all the old bearings and stuff. So we're going to pull it apart, make sure there's nothing internally in the pump itself as well. Pull it apart. I'll go through and I'll check the we'll check our clearances and stuff too, just while we're at it. See if we can chuck a feeler gauge in and make sure it's all good. I'll also have a look at porting this oil pump as well, just while I'm in there. Get out the old Dremel and clean up the back radius of that. And yeah, let's get into that. Ooh, yeah, nice. So as you can see there, we're going to clean that up. A bit of material's gone through the oil pump here and it's kind of shoot into the face of that. It's not too bad. It's a little bit chunky, but it's not too bad. We'll clean that up anyway to make sure it doesn't create any more debris or anything. A little bit of scoring on the back side of it. Nothing too bad. And nothing really bad on the front, which is what we want. So we have something that we can still use, which is good. The main reason for taking this piece off is because I want to get the compressed air in here and blow any metal debris out that way. Obviously that's a pickup, it pulls oil in, gets caught in the screen and we want to blow it back out. Make sure it doesn't contaminate the motor. I'm going to clean all this excess assembly lube off as well. Give her a good clean up, make sure she's torqued down, make sure these faces are clean, and yeah, get into it. Further inspection actually. Let's just about chuck this bad boy in the vise. You can see there, it's actually been dropped at some point. And that surface there is no longer flush, so I'm going to get the file, I'm going to clean that up too. Yeah, we're going to chuck it in the vise and we're going to get the carbide bit, clean up the sharp edges all up in here. So you can see, maybe, you can see in there, the oil does kind of a 90 And those sharp edges are what causes the cavitation. We just want to roll them over, smooth them out, and
race or non-race bearing. In studs and fact.
Alright, so all things ported, polished, clean, wiped down. All this is clean and wiped down, all good to go. Our clearances and everything are good. Now we just have this little issue here with the corner of this. So you can see it's got a high spot, and let's go like this. So I'm going to take material off the top there, and that's exactly what I plan on doing, just taking it down until it is actually level again.
Just like the block and the pistons, the crank and the block have a relationship that over time can develop its perfection.
So it's quite an important mating phase because this is the high pressure side, so oil comes in this side, gets pressurized and pushed out through here. If that's not sealing properly, then we are going to have a slight issue, well, a very large issue actually, but a drop in oil pressure. Not good, not good. So all we're trying to do is get this face here flat.
There are variants available that are going to be 1,000 of
Alright, so oil pump is done, ported, and all that good stuff. We now go about installing it on our motor. So, straightforward process. Our bolt is already kindly installed by the previous builder.
For example, if you had a Honda B series,
I am tempted to pull it out and check it though. Just in case. Essentially, when you're the builder, everything falls on you. So if something lets go on this motor, it's on me. That's why I have all my notes, make sure everything's checked. What I'm going to do is chuck this bad boy on, line her up, bring it out.
The wet sleeve often has an integrated deck design which helps keep the cylinder in line at the top.
K20 chain, K20 oil pump.
Thank you for watching this video. We understand it's a lot of information and some of you may have to watch it more than once to kind of process it. That's totally okay, it's a lot to digest. If there are any questions you have, or if you just want to reach out and pass this to us and have us help you through the process, feel free, that's why we're here.
Let's go across a little bit down.
It's Andre from the High Performance Academy. Welcome along to this webinar where we're going to be investigating some of the aspects to do with cylinder head gasket sealing. This is obviously not a big issue on standard engines where you're quite capable of getting away with it.
We got the 2 bolts here, cleaned up, should have a third there,
from our engine,
but there is not.
really a limiting factor into how much boost pressure and then of course of the gasket.
So pump is on, torque down. This one went on pretty good actually, nice and tight. What we can see here is it is the wrong tensioner. So the tension technically it would work, but you can see this third hole won't line up. Now I believe that's just the specific type of tensioner it is. I'm going to try one from one of these other Ks and hopefully that lines up. And we'll just have to get a new one for another one of these Ks. Yeah, so I'm not entirely sure why this particular one doesn't line up. I believe it might be because it's from the Z family. That's K20Z4 head, and probably reuse the parts from it. So I'll take these bolts out, fuck this off, put the guide on the other side, and we'll try and find a oil pump tensioner, oil pump chain tensioner that actually suits and bolts on with 3 bolts, because 3 is better than 2, you know, because if this starts to flex and move out like that, it could be not good. We have the oil pump back on, so we're looking good. We've got our guides and everything on, but as you can see with this particular pump, which looks like it was actually cast and made specific for a K24 block, it wasn't notched as usual, like manually notched, as in I don't believe it's an OEM Honda replacement pump. You can see that one of our bolts is considerably off. These are notched, this one here and this one here, they are notched. You can move it around and you can get it closer to that hole, but that gives far too much tension on the chain. Where it is here, it is good. And you get a good amount of tension. She rotates, moves freely. There's not too much slap or anything like that. She's good. Oop. Helps if this is locked in too. And if we go, there we go. Helps if that's locked in. But might have to notch this hole, just get one more bolt in, because we don't want this flexing and kind of fatiguing the steel and then breaking in the future. So likelihood I have to notch this hole, and yeah, we'll see how we go with that. And just cracked off the 2 bolts. You can see the witness marks there where they can sit, and yeah, that's still fairly well off. You can get it a little closer, but obviously the closer to this you get, the tighter it is on the chain, and we want some tension, but we don't want a huge amount of tension, so don't want to be kind of wanging on it, stressing it out too much. So I might notch it a bit and see how we go. My preference is just to have it about here, so we'll get on to notching. And we are good. So notching it certainly helped. Tension's about right. Not too much, not too little, it's not going to skip, and it's not going to prematurely wear it, so we're good there. And yeah, still not 100% sure why it needs to be notched. I find that very peculiar, but oh well, is what it is. She works, she's good. We're going to chuck the windage tray on, so I'll do that now, and then I think that pretty much calls it for this part of the video. And here we go, is our windage tray. Yeah. Fairly dirty, this particular one, and I always like to check these little machined cuts, or these pressed cuts. Some of these windage trays I've noticed have swarf, like shards of steel from the press still sticking out, and if that gets loose and gets into your motor, yeah, end of story. So it's always good just to have a quick peek and see what the condition's like. They should actually clean up pretty well. A lot of this old grease should have been wiped down, wiped off before it was reinstalled into the motor, but I'll get it cleaned up and get it torqued down, and yeah, go from there. Alright, so that's this video done. That's everything that we aim to do today. And free rotation. Nice, Gary. Pump is ported. We got our baffle tray and everything on there. The windage tray, we had to notch the tensioner and stuff, but that's no biggie. Everything's clean, everything's assembled, everything's torqued to spec, everything is looking good. Next up, given that this is the end of this video, that's pretty much all I'll do on this today. I'll get out the degreaser and brake cleaner, and I'll just clean this stuff off camera because, well, no one really wants to see that. Next video, so the next one, a little bit more exciting. We'll be doing the VTC. We need to check piston to valve clearance. So I know people have gotten away with these pistons and kind of just slap them in away you go, no issues, no piston to valve clearance issues or anything like that. But I like to have my numbers, I like to have it measured properly. So what I'll be doing is using the Track Tough kit, and we'll be locking VTEC, and we will be locking it at 45 and 50 degrees VTC and claying the motor, just to make sure when I do send it to the tuner that he has full confidence that he has full movement of that cam advance. Like, he doesn't need to worry about anything, he can just go ham, just send it, especially in the mid-range, bring up that torque a bit. And yeah, that's the next video, but thank you for watching. Like, comment, subscribe, see anything that I do wrong or things that you want to know more about. Like, I don't think I really got too much footage of porting this guy. I might be able to get some photos off my phone there, because I did take some photos of the actual angles and stuff. So any queries about that, hit me up, and yeah, peace.